line with the last lecture, wherein we were having a discussion of closures of binary relation. Closures, we have already seen. You can have a reflexive closure, you can have symmetric closure. We have seen a couple of examples as well. What do you mean by reflexive closure of a binary relation? It's the smallest possible binary relation possible on R, which will have all reflexive pairs for the given set on which relation R has been defined. Symmetric closure, it is again the smallest binary relation which perhaps contains all the possible symmetric pairs of the given relation on the set on which it is defined. Moving further, the another type of closure, this is very important, transitive, and based on this we are going to have one important algorithm in the notion of discrete mathematics known as Warshaw's algorithm that we will be looking at. Okay. So what do you mean by transitive closure? First of all, the definition of transitive closure. Okay. It's the smallest transitive relation containing R. Okay. Transitive relation which containing R. So we will be provided with a set and the binary relation on that set. Our task is to compute transitive closure of the given relation. So what to do in this case? You will be looking out for all the transitive pairs so that the given relation will look like a transitive. It will satisfy the property of transitive binary relation. So this transitive closure, it is denoted by the symbol R star. Okay. R raised to star, R star. Hence onwards, whenever there is a symbol R raised to star, it will be related with transitive closure of a given relation. What is the syntax? Syntax for computing transitive closure. Okay. Let A be a finite set with n elements. Cardinality of A is n. And further to this, let R be a binary relation on A. Then R closure, how we are defining R, transitive closure of R is given by R union R square union R cube union up to R raised to n, where n is cardinality of E. N is what? It is the cardinality of E. So number of elements present in A are given by n. Okay, that we are writing. So how we are computing R closure? Have a look. Okay. This raised to symbol is used. Okay. R closure, you can write directly R raised to star is nothing other than taking the union of R with its composite, that is R square. What is R square? R composite on R. Union R cube. What is R cube? R square composite on R. You will continue this till you reach the raised to power as the cardinality of E. In simple, you will have at last R raised to n. I hope my voice is also clear and you are getting the screen properly. Okay. We are having around 42. Anything in the chat box? No. Only yes. Okay, fine. Okay. You will understand this with the help of example. So example number 21. Let A equal. I am taking it very simple so that the concept will be clear. Later on we may extend it for other things. Okay. R equal to, let us say, 1 1 2 1 1 1 1 2. It is given. Okay. And what is asked? Find transitive closure of R. So So see, I am first explaining the first example, and later on you can try for second and third. Find transitive closure of R. As per the definition, what is transitive closure? R star is equal to R union R square union R cube. Okay. What is this? N. What is the cardinality of A in this case? 2. So we will have R union R square only. We are not going to go for any other powers because the cardinality of A is only 2. So I have taken R union R square. So do I have R? Yes, I am having R. Let me try to compute R square. So what is R square? R square is R composite R. So how to compute composite of binary relation, that you are quite aware of. 1, 1, 1, 2. So what is the new pair for? I will have 1, comma 2 in my relation. Okay. 1, 1, 1, 1. So I will have new pair 1, comma 1 in my R square. Okay. 1, 1, 1, 1, 1, 1, 1, 2 over 1, 2. Anything which is starting with 2 and present here, that we are observing. 1, 2, 2, 1. Okay, there is nothing which is starting with 2. 1, 2. So we will not have anything corresponding to 2. So we will have only these two pairs present in R square. Are you ready? In case something is wrong, let me know. I think it is clear. Now, what is R closure? R raised to star. What it is? We have to simply take union of this R with R square. So obviously, I am observing that both the pairs are common. So in this case, the relation itself is in transitive closure form. 1, 1, 1, 2. If I take this 1, 1 common, A, B, B, C, I am having resulting relation as A, comma C, which is present. 1, comma 2 is present. Thus, this is our transitive closure of R. I hope it is making a sense. Okay. Let us move on towards the next example, which you will be trying. Let me check out if you can work on. Okay, let P be a set comprising of 4 elements, 1, 2, 3, 4, and let S be a relation defined on P, which is having pairs 1, 2, 2, 3, 3, 4. Question is, find transitive closure of R. S, okay, not R. So that you have to find. Let me know the answer. In the time, I will write the next example. Let A equal to B, comma B, comma C, comma D. Let R1 be a relation defined on A having pairs BE, BB, CC, DB. If this is not visible, let me make it visible first so that you can take it down. Okay. Let R2 be a binary relation on again same set A, which is having pairs AA, BD, AA, BD, BC. What is the task? Task is very simple. Find R1 union R2. It's transitive closure that we need to find. R1 union R2 star, that you have to find. Any problems? Anything to discuss? Any problems so far? I think you are now solving. Okay, and there are no problems. Fine. Good to see that there are no problems. Be quick. What is the transitive closure of S? Any replies in the chat box? Is there anyone who has tried to figure out what will be the transitive closure of S? Yes, somebody has given the answer. Okay, I'm observing that. So those who have given the answer with 5 pairs, their answer is wrong. You will have total 6 pairs in your answer. You have to cross check. So I think Prathamesh has given the answer which is having 6 pairs: 1, 2, 2, 3, 3, 4, 1, 3. Then he's saying 2, 4, and 1, 4. Okay. Yeah, correct. So this is the answer that you should get, whatever Prathamesh has given. No? And others who are having 5 pairs, you are missing 1 pair. You should have total 5 pairs as your answer. Okay. So this should be your answer. If you are not getting this, let me know. I am there to help. This should be your answer probably. This is your S. Yeah. Right. Yes. How to find this? How to find this? How we are going to have this solution? First of all, I need to know what will be there in S closure. In S closure, I am going to have S union S raised to 1. That is already been taken care of. S union S square union S cube union S raised to 8. Why we are limiting up to 4? Because cardinality of set on which relation S has been defined is 4. So we are saying this. We have to first compute S square, then go for computing S cube, then go for computing S raised to 4. Sometimes you may have a particular composite relation as null as well. So we are simply taking out the pairs, isn't it? Nothing else. Okay, so what are the contents of S square? In S square, I will have just put S twice. Okay, 1 to 2, 2 to 2 to 3. So I'm going to have definitely a pair 1 comma 3. Okay. Then the other pair in S square, I would have each 2 to 3, 3 to 4, 2 comma 4 in S square. In S cube, we will have only one pair, which will be 1 comma 4, and you will see your result as this one. Okay. Any problem so far? Any other chat? No. So are you getting, or should I solve? As this is very first example, let me try out if you are not getting. So what is S square? For your understanding, I would suggest you to write this composite, this S composite S. So what is this? 1 to 2, 2 to 3. So we will have new pair form 1 comma. Okay. Next, look out. 2 to 3, 3 to 4. So we will have a new pair form which is 2 comma 4. So only this much will be present. What is the principle of composite? If we are having pair A comma B in first relation, pair B comma C in second relation, we can derive a new pair A comma C. So that is what I am doing. 1 to 2. Assume this as A, B, B, C. So you are getting a new pair as 1, 3. In the similar manner, 2, 3. This is A, B. B, C. So 2 to 3, 3 to 4 will result in 2 comma. This is your S cube. If you do for S cube, what it will be? It will be S square composite S. What it is? S square composite S. You have to simply copy paste your S square. Those who are not getting, okay, for them I am explaining. There should not be any hesitation in understanding. This composite with this entire relation. Let me copy this. Yeah. So what is this S cube? 1, 3, 3, 4. So I could form probably only one pair SC. Okay, that will be one form of. You cannot form any other pair. And further to this, what is S raised to 4? So you have to simply copy paste this. So you will have your original relation multiplied by this pair. 1 4. Okay, as I could not see anything which is starting with 1, it is present. Okay, but there is no element which is ending with 1 and present here. So obviously S raised to 4 will be your MPC. And final task is taking union of all S with S square with S cube with S raised to 4. You will have your final answer as this. Any doubts? Any doubts? To be proceed? Okay, have you got the answer for second as well? Second is requiring taking union and thereafter you will compute the composite. Any doubt so far? I am waiting for your answers. Okay. Only 48 are present. Why? Because this is the last lecture. You should not miss any lecture of mine as well, okay, at least. Otherwise, it will be harder for the problems in your regular exams. That is for sure. Now, can you tell me the answer for this? Another thing is let me have. So what is this? First of all, we need to compute R1 union R2. Simply take the union. A, B, B, C, C, A, B, B, D, and D, C. I will have these many pairs. Okay. A, B, B, C, C, A, B, B, D, and you would have D, comma, C as well. So this is your R1 union R2. Consider this as one relation. Let us say S is equal to R1 union R2 is equal to this. We have been asked to compute closure of S. So you have to expand this S up to power 4. S closure will be again S union S square union S cube union S raised to 4. Any answers for this? I'm waiting for your answers. Or till you're solving. It's supposed to have another question that you can try as a homework. Okay, not here. You will be trying this one only here that you are solving currently. This is for homework. Let t equal to 1, 2, 3, 4, 5, and 6. And let, okay, I'm writing this here. Let R be a binary relation defined on A. It says R equal to pair small p comma small q such that p square equal to q. Find R closure, transitive closure of R. Okay, that you have to copy. So take it, snapshot, and try to figure out as a whole. Yesterday there was one problem. Okay, you have been given a 12 points on a circle, and I think you were asked how many lines can be drawn, wherein every line will have only 2 points crossing. Many of you have given the wrong answer. I do not understand what is the confusion that you had while solving that example. I am waiting for your answers. Yes. Can you give the answer for the second example? Example number 23. Whether all are working, let me check out how many are present and who are working. Okay. Abha Singh, Abhishek Bhor, Abhishek Lambate, Aditya, Akansha, Ashish, Maheshwari, Chakia Pradhan. Pranav, you have also scored good. I think you have obtained 23 on 25. Pranav Mahamni. Pratiksha score is very low. Rohan score is again low. Okay, who was absent? I could check. Shubham Nikam, I think you were absent for my test, which was scheduled yesterday, isn't it? Sunny Viraj Rao, Siddharaj Pawar. Okay, Siddharaj Pawar, you were also, I guess, absent. Whether you were present? Siddharaj, have you given the test? Yes. Okay. No problem. I have not seen your answer. Okay. No problem. I was asking you, have you given the test? Okay. You are saying yes. Oh, no problem. So whether things are going fine or need some sort of revision. See, yesterday university has declared the conclusion of this semester, which would be in the month of December probably. Okay, coming December, and university may decide to have your examinations as well after December. So you should be ready in every situation. You must not be having any confusions related with any part whatsoever we have discussed so. Okay. Now I am expecting your answers for the second example. Be quick. Yes, can you tell me the answer? Do I ask? Vaibhav Gaikwad. Vaibhav, can you give answer of second? Solving. Okay. Go ahead. Solve it. Can you please show the presentation screen again? No problem. And that shows here. Now, Abhishek, do you want this one or the next one? Yes, I have shown. Okay, you could see Abhishek. This one, okay. Go ahead. I want the answer. For your simplicity, I will tell you how many pairs you should have. Okay, I think Viraj has given the answer. You should have total 9 pairs in your answer. Prathamesh has also given, no? So let me check out 1, 2, 3, 4, 5, 6, 7, 8, 9. Those who are getting those 9 pairs, the answer is correct. Okay, what are those 9 pairs? You should have AA, BB, CC, BD, DC, BC, AB, AC, and AD. I repeat. Okay. Yes. You should have AA, BB, CC, AA, BB, CC. Then you should have B comma D, D comma C. Then BC, AB, AC, AD. You can cross check your answers. I will write the solution here. And in case you are having problem, let me know. Exclosure. What exclosure is? Exclosure is going to have all these pairs first. Okay. First of all, it will have all these. So I will copy paste. Yes. It is having AA, BB, CC, AB, BD, DC. So original 6 pairs, and we are going to follow new. So new pair formed will be A comma D. Next, you could have on C, you could have B comma C, and you can probably have A comma C afterwards. Okay. Yeah. So these are the 9 pairs that you should have in your answer. You can watch. Okay, what is the trick? Trick for having trick, you should be habitual with these examples. First of all, copy down entire the relation. So up to this point, I was having my original relation. Then I will go on checking out if I can form a new pair. So I will say AA, AB. AB is already present. I will say anything else which is starting with A and present, no. So I am saying AA, AB. So AB is present. Okay. Next, BB. Let us check out BB, BD. So we are having BD already present. Okay. C present. Okay. Next, ABD. So if you look out at this pair ABBD, you could observe we can find pair A comma D which is not present. So I have included A comma D. Right. Next, I will scroll it down. BDDC and pair. Yes, BDDC will give me B comma C. Further to this, you have to again cross verify. You could now see there are 2 pairs which have been introduced. Okay. AD and BC we have put it. So I will say ADDC. Does it form a new pair? Yes, it forming a new pair which is A comma C. So that will also be present in your fine. Proceed. Any problem so far? At least say yes or no. Any problem so far? Okay. Sunny, can you answer this? Exercise. Not going to ask you what is the answer, but you can perhaps take. So let us say you from 10. And then asked again, S be a relation which is having pair A comma B such that A is less than equal to, this will complicate the thing. Okay, so what? Let me have A minus B equal to 4. This also you have to try as an exercise. Find S closure, S star that you have formed. So looking out at these examples, can you tell me what is the drawback of this method for finding the transitive closure? Is there any drawback or it is simple? I hope my question is clear. I am asking you what could be the possible drawback of this method. Is there any drawback? Yes. Disadvantage, I am asking. Okay. Yes, drawback. whether this method that we are using for computing the transitive closure, whether it is easy or it is having some drawback, that I am asking. Lengthy, yeah, it is lengthy and complicated. Need to find composite for 10 times for the example number 25. Okay, so as the cardinality of given set on which relation is defined increases, this procedure, this method becomes complex, okay, and complicated. So what is the alternative? So we can find transitive closure of a binary relation using Warshall's algorithm as well. This algorithm is very simple in comparison with the first method that we have used. This is also used for computing transitive closure. So this is the point that we will be starting for today. Transitive closure of R using Warshall's algorithm. I will not take much. Okay, I will take very simple example for today, and we will discuss this in a detail in tomorrow's class. So just have a look. Example number 26. Let A equal to P 4 5 and R equal to. I'm taking it very simple as much as possible, look, so that there will not be any need of having anything extra. Okay. So these are the 5 bits, and we have been asked to compute. Specifically in exam as well, they will ask you compute transitive closure of R using Warshall's algorithm. R star using Warsh. So my suggestion to all, do not write anything, just observe what I am doing. No? Once you understood this, you will be able to do anything as and when required. Try to first of all get this. So how this Warshall's algorithm works? Solution. It works in stages. Stage number 1. Represent given relation using matrix. So we are going to have matrices in Warshall's algorithm. So the first and the number of matrices that you will be drawing using Warshall's algorithm will be equal to the cardinality value of given set. So we will have 3 Warshall's matrices here. So I will start with Warshall 0, the Warshall's matrix at the 0th level, which will be matrix representation of R. Remember that this should be in suffix W0 equal to MR. So let me write that matrix. Okay, how many rows and columns it will have? 3 rows and 3 columns. Okay, 3, 4, 5, 3, 4, 5. So 1, 1, 0. If I am going wrong, let me know. Okay. 4, 3 is absent, 4, 4 is absent, 4, 5 is present. Next is we are having only the pair, which is 5, 5. The very first step is representing the original relation in the Warshall's form. This is known as Warshall's matrix. Matrix at state number 0. Is it fine? Is it fine? Should we proceed? Only 2 more minutes that we are going to take up, not much. Yes. So first this one. Now the step number 2. Find W1 using W0. Okay. W1 means I have to look for. Okay. Please observe carefully. W1 means I have to look for first column and first row in Warshall 0. Are you getting my point? First row and first column in Warshall 0. You will be adding 1 if you are getting corresponding entries likewise. Okay. So let me try to highlight this so that it will be clear what we are discussing. Nothing. We have to look for this. Yeah. So first column and first row, and check out where you are having 1 present. Okay. So for R1, I am observing that 1 is present at column 1 1 is present at column 2. And for column 1, you could observe that 1 is present at R1 only. Are you ready? Are you ready? This particular point, I have there is no confusion so far. So based on this understanding, we have to formulate a new pairs. We will say R1 will be paired with C1 and R1 will be paired with C2. So, okay, if this is making confusion, first of all, write for columns. What I am writing? Column 1 is having, okay, for your information, I will write it like this. 1 is present at R1, row 1. Let me write it like this. For row 1 is present at C1 comma C2. So form pairs corresponding to this R1 C1 R1 C2. Now check out. R1 C1 is already 1, R1 C2 is also 1. So okay, as these pairs are already present, no need of going for any modification. So you will say W1 equal to W0. There will not be any modification. We will have the same pairs. But in case you have got a new pair, you could have added it. In this case, there is no need of. So let me again go to none. Okay, now what we will do? Step number 3. Step 3. Find W2 using W1. Now considering W1, we are going to go for second column, second row. So I will say this is second row. This will be your second column. Let me try to, just for your understanding, and as this is the first example I am doing this, I will not do it, okay, for any of the next lectures. This is not required. And I think this one is required. Okay, fine. Fine. Okay. Now what to do again? The same task, we have to check where 1 is present. So for column 2, 1 is present at column 2, 1 is present at R1 only. R2, 1 is present at R2. Okay, for R2, 1 is present at column number. Are you waiting? Column, when we are observing column, we have to look for row. So for this C2, I am observing that 1 is present in first row. If I consider row 2, 1 is present at column 3. So what to do? Form a pair. Which will be that pair? That pair we will have as R1 comma C3. Look out whether R1 comma C3 is present originally in this. Okay, R1 C3. So that is not present. That means we will be changing this 0 to 1. We have added this pair. Okay. You will observe from this. So the pair T4, 4, 5 will result in 3, 5. That is the meaning of this. Okay. To form a pair, add this to W2. So what is my updated W2? W2 equal to. So I am again going to copy paste these, but this will be slightly changed. This 0 will now become 1. How this has become 1? Because we have added a pair R1 comma C3. R1 corresponds to row 1, C3 column. Am I clear whether it is heavy or it is very simple? Heavy or simple? Whether it is making sense? Simple. Okay, fine. Okay, fine. So what will be step next? Next step number 4. But once the examples are complicated, you are going to make a silly mistake that I am aware of. Okay. Step 4, form W3. Okay. Up to where? Up to the cardinality of given set. So we will stop at W3. Okay. W3 will be our final matrix. Form W3 using W. Quickly tell me what will be now present. Okay. We have to consider now the third column and third row. C3. 1 is present at C3, 1 is present at R1, comma R2, comma R3. R3, 1 is present at C3. I'm observing this. So what are the new pairs formed? Of R1, comma C3, R2, comma C3, R3, comma C3. So I will check out if that is actually existing. Otherwise, I will go on adding. So what is W3? It will be the resulting matrix that you will have. Okay. So we will check out. So what it is saying? R1 C3. Okay, that was already present. So I will copy R2 C3. R2 C3 is present. R3 C3 is also present. So this is our final matrix. Now again convert this to original relation. This will be R closure, that is equal to W3, which will have pairs. Which are the pairs present here? So I'm going to have 3 3, 3 4, 3 5, then 4 5, 5 5. This will be the smallest transitive relation, transitive closure. So you could observe, because of 3 4 4 5, a new pair 3 comma 5 is formed, and that is present. Is it fine? What is Warshaw's algorithm and how to make use of it? Steps are: represent given relation using matrix, then check out for W1, W2, W3 up to the cardinality. You are going to play with the matrices, nothing else. Is it? Is it fine? Is it fine? Yes. Now quickly type your roll number in the chat box. I know that this is lunch time. I am not going to take your much time. Okay? Type your roll number in the chat box and we will stop for today. Okay? You can leave the meeting. Okay. The suggestion is you can try for other examples which we have taken using the normal method. Just use the matrix and check out whether you are getting the same thing. Okay. More on this in tomorrow's class.